In section 3, we're going to be looking at solving trigonometric equations. And our first method for doing that is by just isolating the trigonometric expression. Here we see we have a cosine on both sides of the equation. So if we subtract the 3 cosine x from each side, we have 2 cosine x equals the square root of 3. And dividing by 2 on each side to move things away from the variable, just like our normal equation solving, makes it cosine of x equals the square root of 3 over 2. And this is one of the reasons that our unit circle is so important. We need to think about, on the unit circle, where is the cosine, the square root of 3 over 2? Well, that's going to be in the first and fourth quadrant where cosine is positive. So we have in the first quadrant, the angle here, theta, is going to be pi over 6. And in the fourth quadrant, we can think of it as going backwards pi over 6. So from 2 pi, or 12 pi over 6, we're going to back up 1 to 11 pi over 6. So we have pi over 6 and 11 pi over 6, but those aren't really all of the solutions. Those are just the two that are between 0 and 2 pi. So to get all of the solutions, we're going to extend that by adding the 2 pi n to each of those for n, an element of the integers. Try this guided practice problem on your own and record your response. The answer is, did you catch that? We'll do it one more time. The answer is C. In the next example, we see that we have a tangent squared. So if we just treat this like a normal everyday equation, thinking of the tangent squared of x as being our variable, we would start off normally by adding 4 to each side. So nothing unusual there. So we have 3 tangent squared x equals 1, and divide by the 3. So we have tangent squared x is 1/3. And now, to get rid of the squared, we're going to take the square root of each side. And don't forget, when you take the square root of each side of an equation, that we have to put in the plus or minus. So square root here, and we're going to put in a plus or minus the square root here. So we have the tangent of x is plus or minus the square root of 1 over 3, or 1 over square root of 3, which we recognize as being the square root of 3 over 3. So we've got to figure out where the tangent of x is the square root of 3 over 3. So we'll start off just looking in the first quadrant and then go from there. We know that this is going to include all 4 quadrants, because tangent's going to have this value of plus or minus the square root of 3 over 3 in each of the quadrants. So we want to think about our sine and cosine values. We know each ordered pair is a cosine and a sine. So if we look at the pi over 6, we have radical 3 over 2 and 1/2. So if I think of sine over cosine, that would be 1/2 over the square root of 3 over 2, which is 1 over the square root of 3. Okay, so that's the angle I want. So I want a reference angle of pi over 6. So that's going to go over here, here, and here. So I've got pi over 6 as the first answer. Second answer, coming around to this, well, 6 pi over 6 would be all the way to the x-axis. So that's going to be 5 pi over 6. Infinitely many solutions, and so the others are given by adding pi n. Be careful, remember the period of tangent is pi and not 2 pi. Try solving this equation in your notes and record your response. The answer is D. And there it goes again, follow the bouncing ball.